So let's take a look at this question now. It's actually from M2 because obviously most of the M2, in fact, all of the M2 is included in the further mechanics. So I thought to write some here. So what I have here is a particle P is projected from a point O with speed V at time t second after projection. The horizontal and vertical. Okay. So it means that when we start the projection, all right, then we do it at a velocity v, angle theta, and the displacement from of p from O are x and y respectively at a certain time. So if you want to rewrite this as a form of trajectory, the way we do this using usual notation is y equals to x tan theta minus gx squared divided by 2 u square cos square theta. U square is the starting velocity, the projection velocity, and theta is the angular projection, and x is obviously displacement. And now, what this question says is that I just need to compare this with that. I just have to replace some of the things here, just this much. And in this case, if I notice, tan theta is 2. When t equals to 4, p passes through, basically, look at this. X is this one, and then 2 is that, minus x squared is at the top, b squared is at the bottom. So we need to do something with these two. And also, by something I mean we have to be careful about, we also have to be careful of the fact that g is 10 meters per second square whenever we need to use it, which is something we do have to use it here. So when t equals to 4, p passes to a point A where x equals to y equals to a. So it means that when t equals to 4, a equals to 2a minus 5a square by b square. This is equation 1. And also I need to find out the values of g and this whole thing. So basically we notice that if we actually rewrite this thing like this, then we actually have x squared and b squared together. So it means that g by 2 cos square theta, or 10 by 2 cos square theta, or 5 by cos square theta equals to 25. Cos square theta equals to 1 by 5. So cos theta equals to plus minus root 1 by 5. Now, because we want cos to be positive, and in fact, theta is supposed to be the angle of projection from P, usually we consider to be acute. So as a result, we have to assume it to be theta equals to just cos inverse root 1 by 5 whenever we need it, or 1 by root 5. Now what I need to do is that if I had this adjusted, then it means that if we go back to this equation, then we have a equals to 2a minus 25 a square by b square, and in this case b square. So in this case, if you go back here, then we rewrite this thing as a equals to 2a minus so it means that it is going to be 1 by root 5 here, or actually 1 by 5. So it's the exact same thing actually. Okay, I'm just going to do it at t equals to 4 separately now. So combining these two, we have this equation, which I'll need later on. But if I use them separately, then we know that it's easy to just do it with horizontal velocity, because we know cos theta equals to this one. So I can just directly use for horizontal case scenario, because horizontal velocity is always constant in a trajectory. Then then if this is b, then it is going to be x equals to a equals to b cos theta into 4, or 4b cos theta, or 4 by root 5t. So it means that this equals to a. That means that b equals to root 5 by 4 into a. So it means that a equals to 2a minus 25a squared by 25 by 16a squared. A equals to 2a minus 16a squared. So 16a squared minus a equal to 0. A 16 minus a equal to 0. A equals to 0. A equals to 16. Now, obviously, x and y is same. Obviously, we start from t equal to 0. So it doesn't mean, so if we start from x equal to 0, then it definitely means that we are not starting from the origin, even though this one doesn't make too much of a sense to me for the time being, where the velocity should be the same. I mean, what we're trying to do here is that we're just trying to say that the x and y coordinates are exactly the same. But obviously, in order to do that, there are two possible cases where both of them are 0 or both of them are 16. So a has to equal to 16, otherwise we would not get there. This is the first answer. And then for B, I have 4 root 5. Let me check because I'm skeptical. Wow, okay, actually it's not 4 root 5, it's actually something a bit different. So uh, it is this into t is 4. Yeah, it's actually not 25, it's actually just 5. So we actually have here 5. So it means it's actually 80. If this is 80, this is 80. If this is 80, this is 80, this is 80, then it means that B equals to 20 root 5. In this one, what I have to do is that I have to find a direction of motion of P when it passes through A, which means that it gets to A here. It has a certain velocity in both vertical and horizontal direction. I just need to find the angle. So it means I need to find the vertical velocity now. And it's going to happen when I travel a distance of 4. So it's going to be vertical velocity equals to u or 80 root 5 sine, because it's sine, cos inverse 1 by root 5. The initial angle is 1 by root 5 minus 10t, or it's actually 40. So if we do that, then we realize that what is that? Let me see if I can try doing some. Okay, you know what? I'm just going to use my calculator. We get sine cos inverse 1 by root 5 80 root 5. No, it's 20 root 5 minus 40, 0. So it's 0. And my horizontal, actually, now what I have to do is that this angle is theta. We actually need tan theta equals to vertical velocity by horizontal velocity component. This is 0 by something. So if tan theta equal to 0, then theta equals to 0. This is my answer.